Today we'll be going over the notes for targets 8 and 9. We'll actually start with target 9 and then work back to target 8. So target 9 is over a process called synthetic division. We use synthetic division when we want to divide two polynomials by each other. We can use this to help us factor. We will eventually be getting to that for things that don't work with some of the methods that you've already learned. So synthetic division, the first thing that we would want to do is looking at our division problem. We want to make sure that everything is in standard form, i.e. you want to make sure that that highest exponent is first. So we have x squared first here minus 5x plus 4. So it's in standard form there. So when we fill out our synthetic division, we're always going to do this model. We're going to have almost an L shape here. So if this was my lined paper, I'd have a line here, I'd have a line here, and I'm going to have a line here. And then we're going to fill in those values. So the first thing that we want to do here is it says carry down the one that is the leading coefficient. So you're probably wondering how we got the numbers down here. 1 is my leading coefficient on here because it was 1x squared. Then it was negative 5x, so we filled in with negative 5, plus 4, so we filled in with a 4. If we were missing a term for our original polynomial, we would want to fill in 0. So what that means is if this looked like x squared plus 4 originally, we're missing that 0x, so we would have 1, 0, and a 4. We won't have to worry about that here because we weren't missing any terms. The next thing we have to figure out is how to get this number here that you're going to see on the outside. In this, we're dividing by x minus 1, so we're always going to take that and set it equal to 0 and solve for x. So x equals 1, and that's how we get the value on the outside of that L. So step 1, it said first carry down the 1 that is the leading coefficient. So the first thing we'll always do, draw an arrow down and bring that 1 underneath your bracket. Okay. It says for step 2 then, multiply the number on the left and carry the result into the next column. So we're going to multiply the 1 on the bottom by the 1 on the outside. 1 times 1 is 1, so 1 fills in my spot underneath negative 5. I'm going to add negative 5 plus 1, and I get negative 4. We're going to repeat this again, though. So I'm going to take negative 4, and I'm going to multiply it by the 1. So you're always multiplying by the number on the outside. So negative 4 times 1 is negative 4, so I'm going to fill in my next spot there. I'm going to combine those, so 4 minus 4 is 0. I don't have any more columns of numbers over here, so at this point, I know I'm done. So the next thing says, what does this result tell us? Right now, it's just a bunch of random numbers. The order of the numbers will always be our remainder, our constant, and our x term. So on here, I have a remainder of 0. If I have a remainder of 0, that tells me that it is a divisor. So the divisor is a factor. This will always be true if my remainder is 0. Okay. So it says, if yes, write the factored form. Okay, so first of all, let's go back up to that question, what does the result tell us? This tells me the answer to my question up here. So if I have x squared minus 5x plus 4, and I divide that by x minus 1, my answer to that division problem is negative 4 is my constant, 1x. So I have x minus 4. So when I go to write my factored form, I'm going to use that. When I got my answer, I got x minus 4, but I got that answer because I divided by x minus 1. So my factored form is x minus 4, x minus 1. It'll always be what your answer is and what you are dividing by. Okay, let's go down to A and B. I know that might have been confusing. Synthetic division is something you just need to practice over and over and over again. So down here we have to set everything up. So the first thing that I'm going to check is this polynomial in standard form? It is, so I'm going to bring my coefficients down. I notice that there are no missing terms in here. So I bring down a 1, 10, and 13. To get my number on the outside, remember we set what we're dividing by equal to 0. So x plus 7 equals 0. So x equals -7. -7 will go on the outside. Step number 1 then says always to drop your first term. My first term is 1, so I have a 1. Then remember we always multiply this value by the number on the outside. 1 times -7 is -7. I'm going to add these two together. 10 minus 7 is a positive 3. So then I'm going to take 3 and I'm going to multiply it by -7. 3 times -7 is -21. Combine those two. 13 minus 21 is -8. We're done again because we ran out of numbers. There's nothing else left in that column. So I know here I have a remainder of -8. I have a constant of 3. I have an x term of 1. If we had another number out here, if this problem was continued, this would be our x squared term, x cubed term, and so on. But right now it just goes up to an x. So question says, is the divisor a factor? Remember, if it is a factor, then my remainder would equal 0. In this one, my remainder equals a -8, so this is not a factor. So then we go to the if no, write the answer. We still have an answer to the problem. We just have to include our remainder into it, and we're not going to have a factored form. So when we go to do our answer, your answer is made up all of what we have underneath that line. So it says we have 1x, so I'm going to have x. My constant is 3, so I have plus 3. Plus my remainder. Well, my remainder is -8, so we're going to have -8. Your remainder always goes over what you were dividing by. In here we were dividing by x plus 7, so I'm going to have -8 over x plus 7. So there's two types of answers we're going to have here. Factored form if our remainder is 0, or you're going to have a polynomial here, an expression here, where you have a division where you're dividing by whatever you were dividing your original polynomial by. Okay, let's look at B then. So first thing we do is we pull down those coefficients. So my coefficients are 1, 5, and -6. To figure out my number on the outside, I'm going to take x minus 1 and set it equal to 0. So x equals 1. We put 1 on the outside. So start always by taking your first number and dropping it down. So I pull down a 1. We always multiply our number on the bottom by our number outside on the left. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. -6 plus 6 is 0. So 0 again is going to be my remainder. After my remainder will always become my constant and then my x term. So is this divisor a factor? Yes, this one is a factor because my remainder is 0. If yes, write our factored form. So remember our factored form we're going to get from our answer. So my answer on here is 1x plus 6. So I'm going to have that as the first part of my factored form. The second part of my factored form always comes from what did you divide the polynomial by? I divided the polynomial by x minus 1. So the rest of my factored form is x minus 1. Okay, on the back side of your paper, you're going to see we're going to go back to target 8. Target 8 is still using the synthetic process. This time instead of synthetic division, we're going to use synthetic substitution. So synthetic substitution is a way for you to figure out the answer without having to plug it in your calculator. Really, it's evaluating something for you. So in this equation up here, if I have 2x squared plus 3x minus 10, and I ask for f of 5, we know that would mean that I need to plug in 5 for all of my x's. Then we have to make sure, oops, I forgot to put a 5 and I have an x in there. We have to make sure that when we evaluate this, we follow the order of operations. So order of operations tells us to do exponents first. So I have to do 5 squared, so I have 2 times 25. Plus 3 times 5 is 15, minus 10. 2 times 25 is 50, so I have 50. 15 minus 10 is 5, so 50 plus 5 is 55. Now, there's several places there I could have made mistakes. I could have not used the order of operations properly, any amount of things. So we use synthetic substitution to do the exact same thing that I did there. Just usually it's simpler and we don't have to worry about that order of operations. I'm still going to bring down my coefficients of my values in my polynomial. So I have 2, 3, and negative 10. On the outside, I don't have anything to solve for. They didn't tell me x plus 5, x minus 5. They showed me that my x value is 5. So we're going to plug 5 in on the outside. We're going to use the same process again. So I'm going to drop my first. So I drop 2. 2 times 5 is 10. Add those together. 3 plus 10 is 13. So then I do my 13, always multiplying by the number on the outside. So 13 times 5, which is 65. Negative 10 plus 65 is 55. So it says the remainder is 55. Your remainder is always going to be your answer whenever it is synthetic substitution. So we could write this as f of 5 equals 55. Let's look at A down here. So first thing, always make sure you are in standard form. Always make sure that you aren't missing anything. So we have the third power, the second power. We know this would be the first power in our constant, so we're not missing anything. So I'm going to pull down my coefficients. 3, 10, negative 5, negative 4. Again, they tell me my x value is 2, so I put 2 on the outside. Always drop your first value, so we drop our 3. 3 times 2 is 6. 10 plus 6, 16. 16 multiplying by 2, I get 32. Negative 5 plus 32 is 27. 27 times 2 is 54. Negative 4 plus 54 is 50. So I know my answer is my remainder, so f of 2 is 50. Last one, again, making sure it's in standard form. It is, but on this one I see I don't have an x squared term, so I have to make sure I fill in a 0 for that. So for my coefficients, I'm going to have 2, negative 1, 0, 5, and 3. My x value is 2, so 3, so I plug 3 in on the outside. Drop my first term, so I drop that 2 down. And then I'm going to do 2 times 3, so I get 6. Negative 1 plus 6 is 5. 5 times 3 is 15. 0 plus 15 is 15. 15 times 3 is 45. 45 plus 5 is 50. 50 times 3 is 150. 150 plus 3 is 153. So f of 3 equals 153. Please come in if you have any questions.